Good morning, everybody. You may be surprised to note that I'm not actually Pat Morin, despite what it says up there. My name is Simon Pratt. I work with Pat Morin in the Computational Geometry Lab. I'm also a TA for his other course, Comp 2402, which is Data Structures and Algorithms. I'm also the president of the Computer Science Society, so hi. So I'll be giving your lecture today. Today's lecture is going to be a departure from normal. And it's not the reason I'm here. I'm not here because it's a departure. Pat would be giving the same lecture if he were here, but he's away somewhere for the weekend and Monday and Tuesday. So here I am. So today we'll be looking at Java. And I know so far you guys have been looking at Python, so it's going to be a little weird. Java is actually a pretty good language to know. It's widely used in industry. Just to name two places here in Ottawa, IBM uses Java and Adobe uses Java. So yeah, Lexi back there worked at Adobe, so shout out. Anyway, so it's a good language to know, but it's not a great language to teach first. We used to teach 1405 entirely in Java, and we switched away from that really because Python's a much easier language to start with. Java requires a lot of stuff before you can actually start writing useful code. So we'll be getting to that shortly. So Python's really the better language to start with. And then now that you all have Python as a background, I can give you Java within like 2 lectures. I'll give this lecture and Pat will give the next one. So let's get started. Open up the editor. So Java files have a Java extension. Just a quick check. Who here has programmed in Java before? Pretty much everyone. All right. So this will be a bit of a review for you guys. Ampersand. Cool. So yeah, in Java has this philosophy that everything has to be inside of some class. So when you have a Java file, hello-world.java, it has to contain a class inside of it, an outermost class that shares the same name as the file name. So in this case, we have to have a class, and it has to be called hello world. And it's case sensitive, so you have to match the cases in the file name and the class. So you can't have hello world with a lowercase w, it has to be uppercase. And then when we say it has to be inside of a class, in Python this would sort of mean the colon and then some indentation. But in Java doesn't really do that. It has curly braces, and those are what define a block. So all code has to be inside of this class, but it's not really ready to do anything. If you tried to do this as a Python programmer, I would just try to write Java hello world.java, but it says can't find the main class hello world.java. The reason for this is that Java requires an explicit compile step. So Python's also compiled, but Java forces you to do it as a separate step before you actually run anything. When you run Java, you're running the Java virtual machine. So we actually have a separate program called JavaC, which is the compiler, and that's fine. So now it's compiled, and so you'll see this hello world.class. And so what that means is that the compiler came through and looked at all your Java code and turned it into the equivalent bytecode that the Java virtual machine can interpret. So if we try to run Java hello world.class, we'll get another error. So what it's looking for is it's looking for a class called hello world.class. And that's not actually the class that we have. We have the class hello world. So that's another thing that would confuse me if I'd only seen Python before. So what you really ask it to do is you run Java, and you give it hello world, the class name. And if you do that, it's still going to have a problem because we're still missing some piece of Java. I mentioned earlier, Python, you can sort of open a text editor and start writing Python code, Python lines. And the Python interpreter will be really happy to evaluate those lines. Java has a much more explicit entry point into the program. So we actually have to, inside of this class, we have to have a method that the Java virtual machine starts. You're going to call somebody on Skype? Sweet. Anyway, so we have to have an explicit entry point, and the entry point that Java specifies is called public, static, void, main. And I'll get into what this means in just a moment, but trust me that this is a method, so it takes some parameters. Specifically, it takes an array of strings called args. And the way that you put code inside of this method is another block, just like the class is a block, main has a block, and you put code inside of here. And so let's deconstruct this a bit. Main is the name of the method. It's what comes right before the list of parameters. Args, string square brackets args is the list of parameters. It has exactly one thing in this list. Called args, and it's of type array of string. We'll be getting into all this a little later on. But then let's go back to the beginning. Public. What does public mean? Well, when you write a method on a class in Python, by default it's public. And what this means is that other classes, other places in the code can call that method. You don't have to be within that class to call that method. And so there's a bunch of different ways, a bunch of different access modifiers is what they're called. We have public, as we see here. We also have private, protected, and what's called package private. And a lot of people just refer to this as default because it's the default. If you leave out an access modifier, then it becomes package private. So it's the default. So what these each mean are, we've already discussed public. It's what you'd expect as a Python programmer. What private means is that if a method is private, or if an attribute is private, it can only be accessed from within the same class. And that's kind of a weird thing as a Python programmer. By default, you can access basically anything from anywhere. There's a convention in Python where you have some underscores to sort of mark it as private. Like, don't call this, trust me, this is just for my use. But in Java, it's much more explicit. You can say it's specifically private. Protected is a slight deviation. It's you can only access this method or attribute from within this class or any class that inherits from this class. So if we had another class, Hello World 2, that inherited from this Hello World, we could access any protected methods or attributes. But anything outside of it, anything in a different class that didn't inherit from it, wouldn't be able to access those same things. Package private is pretty much the weirdest. If you've ever programmed in C++, the C++ people call this friendly. I don't know much about that, but that's what Pat calls it, because I think he used C++ before he used Java. But anyway, what it means is if you have two classes in the same folder, the same directory, they can access each other's package private methods, but any class that's in a different folder can't. And the reason for this is because Java sort of has this idea of packages, and it links the idea of a package to a directory. So if it's in a different directory, it's in a different package. So that's why that is. So those are the access modifiers. So now on to the second thing, static. What static is because Java has this philosophy that everything has to be inside of a class, it sort of needs a way to say, even though this method is in this class, it doesn't really operate on objects of this class. It operates on the class itself. It doesn't need an instance of what you've created here. And so what that is static. And what that means is that, so normally in Python you would pass in a self parameter as your first argument to a method. So this is the equivalent of not having that. And I think there's also a modifier in Python that says @static method. And then you need to call things like, so normally you'd have a hello world object, and if you declared that, you could run hw.main. That's how you call methods in Java. If instead you have a static method, you just call it directly on the class, like that. So that's what static means. So the next and final thing is void. And void is another weird case of Java's philosophy that everything has to have a type. So every method and every attribute has to have a type. And void is specifically a method that doesn't return a type. In Python, if you don't return something, then the method or the function returns a none. That's basically the same thing. If you don't have a return statement in there, then it has to be void. Otherwise, the compiler's going to complain. And so that's what that is. And so what we have here is the minimum code to run. See here, before we compiled it properly and then tried to run it and said we didn't find a public static void main. So now, one common pitfall that I should point out is because there's an explicit compile step, what often happens is you forget to compile it again. So if we run Java hello world, it's going to still say that we don't have a public static void main, even though we definitely do. The problem is that we didn't compile it again. And so this actually comes up a lot even in like second and third year. People are saying, like, my code seems to work, but it's not running properly. Definitely try to like clear out all of your previous compiles and like try to run it again. So we compile again, hello world, and nothing happens, which is what we expected. It gets into main, and then since there's no code there, it immediately exits. But that's the minimum valid Java program. So not very useful yet. So the first thing that I usually do as a programmer learning a new language is try to print something. And in Python, you'd do something like this, print hello world. But Java is a bit more verbose. It doesn't really have a print function. It has system.out.println. And so system is a class that's sort of built into the language. And on it, there's an attribute called out, which is an object on which you call the method println. And you pass into it this string literal hello world. And so in Python, you have lines of code. In Java, you have statements, and a statement has to end with a semicolon. So that is a proper statement that calls the println method on out, on system, passes in hello world. You can see how that runs. Hello world, yay. So yeah, if we forget the semicolon, that's a really common error. Probably more common than forgetting to compile. But thankfully, the compiler actually gives us a really nice error about this. It says what was obviously going to be a statement didn't include a semicolon. So I expected one, you didn't give it to me. Please go back and fix that. So we do that. And another side effect of having statements, not lines, is that you can have lots of code on the same line. So we could have another system.out.println. World. See if that compiles. Looks like. Yay. But don't do that. I don't know if Pat told you, but you could actually do this in Python as well by using semicolons, but no, there's no reason to do that, so don't. It makes it harder to read, and even though Java is meant to be compiled, at least as often as it's compiled, it's also read. Like, you'll be passing code around and getting people to look at your code like TAs, and they'll need to read your code. You know, reading the code is actually more important than compiling for them. Compiling it is important, but reading is really how you get your points in most cases. So don't do that. And unlike in Python, indentation doesn't really matter. So this is all nicely indented right now. We've got a class, and inside of this class we have a main method. And inside of the main method we have this system.out.println statement. we don't really need to indent it nicely like that. So in Python would complain about anything that looked like this because you're starting a new block and then you have a statement that's not properly indented within that block. But as we can see, Java doesn't care. But again, don't do that. It makes it really hard to read. Yeah. So the next thing in programming languages I'd like to learn is, so that was stuff. Next thing I'd like to learn is variables. And so as a Python programmer, I'd sort of expect to be able to do something like x equals 5. And it's a statement, so it has to end with a semicolon. But Java's not really going to let us do that. It says, cannot find symbol, x, which is weird because it's actually pointing right at x. So it's weird that it says, can't find this. It's right there. But it's what it's really trying to say is, you didn't declare this. I don't know what this is, and suddenly you're talking about it like I know what it is. So before we can start using variables, we need to declare them. 5 is an integer, so we'll make it x an integer. So in Python, you sort of just have these references, and these references can point at whatever. And it's the whatevers, it's the values that actually have types. So the type could be a number or a string. In Java, it has that, but it also has types on the references, and the references can only point to values of the same type. So here we've got an integer x. We're telling Java this is an integer, and then we're assigning to x the value 5, and that matches up. It is an int, and we're putting an int inside of it. Should work out. Yep. In fact, we can do something more useful with it, like print it out. There you go. Yeah. So this declaration doesn't have to be a completely useless line. You can also immediately give it a value when you declare it. So x equals 2, for instance. So then if we print it out between these two things, you'll see x equals 2, and then x is 5. Oop. Exactly as we expect. So thankfully, integers are not the only data type that Java has. We also have a whole bunch of things like bytes, shorts, int, long. And these are the integer-like types. And the difference between them are the number of bits you have. So byte has 8 bits, a short has 16 bits, an int has 32 bits, and a long has 64 bits. And this might be weird in Python. When you need more bits, Python allocates more bits to store a bigger number. But the same is not true in Java. So if you have an integer x, as we have here, and we put some number into it, now here's a neat trick that you may not have seen. In Java, they let you add these underscores between digits just to break it up. It doesn't mean anything. It just lets you see that it's broken up. So you can see really easily that this is a million. I find this useful because it's often hard for me to tell how many digits are there if they're all the same digits and all in a row. So we can easily tell that this is a million, and if we print this out, we should see that it's a million. Yes, that is a million. But what can happen is, because it's only 32 bits, weird stuff can happen if you start getting big numbers. So if we do x times x, we expect a million times a million millions, or 1,000 billion, whatever you prefer. But Java asserts that it's minus 727,379,968. It's not really what I was expecting, and that certainly wouldn't happen if you did that in Python. So what happened is the integer-like types are all signed, so they all have a bit. The most significant bit is the sign bit. And what's happened here is that we've grown our number to the point where a bit has shifted into the sign bit position. And so when Java goes to print this out, it interprets the bits as a negative number, and specifically it interprets the bits as this negative number. So the way to get around that is, if you need bigger numbers, you just have to declare bigger numbers. So make x a long, and longs act exactly the same way as integers. Hello, this is 1405, don't worry. Right, so, but longs have 64 bits, so hopefully this won't happen there. Perfect, I think. Yeah. Millions. Exactly what we expect. So that's overflow. Any questions so far? Yep. Yeah, so that's a good question. Right, yeah, so floats and doubles are a different thing. They're not an int-like thing. So we have floats and doubles, and what they are floating point numbers. And specifically the difference between a float and a double is a float is 32 bits, and a double is 64 bits. So we can use floats like this. That's a double. We can print it out. So ints have to be a number, an integer. It has to be like a counting number. But a float has a decimal point, so you can represent like 1.2 or whatever has a point in it. There's some weird behavior with floats and doubles. So if you have a float f and you try to assign 1.2 to it, it doesn't do exactly what you expect. It says, I required a float, but I found a double. And so what this is that when you do things like this is called a string literal. This is an integer literal. And what this is a double literal. And what's happening here is that we have a double literal, and we're trying to put that inside of a float. And a float has less bits. And so there's a possible loss of precision here. And so it's warning us about it. So the main way to deal with this is to cast it to a float. But you can also make it, there's a way to do a float literal. You add an f at the end. But really, for most purposes, just use a double. There's really no need to save on space for to use a float. I guess that there are some specific cases, like GPUs. Apparently, floats are like 4 times faster than doubles, but don't worry about that so much. Mostly just use doubles. Perfect. And Java has a couple more built-in types. It has the Boolean type, and the character type. So if we want a Boolean b equals true, so what you'll notice here is that this is a character. What this is it's a character literal, as I was talking about before. And you'll notice that it's distinguished by these single quotes. In Python, if you use single quotes or double quotes, you can use them interchangeably to represent string literals. It's not the same in Java. A single quote means a character. Double quotes mean strings. So be careful with that. And if you have these single quotes, you can't do something like that. It's no longer a character. It gives really weird errors if you do that. It interprets the open single quote as starting a character, but then it says J is not a statement. It's trying to follow a character, but it's following an unclosed character literal. And then it sees the second single quote as opening a new character. So be careful about that. Print that out. Perfect. So those are characters. So once we know what data types we have, it's pretty useful to know what we can do to them. And we would normally have the BEDMAS operators that you sort of expect from arithmetic from high school. But we don't exactly have that. We have BEDMAS. So we have brackets or parentheses, division, multiplication, addition, and subtraction. So we saw that up here, multiplying x by x. And again, weird things can happen. If we have two integers and we divide them, like that, then it doesn't exactly do what you expect. I think you guys were importing division from future in Python. Yeah, so what's happening there is the old Python way was the way that Java does it. It does integer division, and we'll see exactly what that does. So 2/3 is 0, which is a little weird. It's definitely not doing rounding because 2/3 would round up. But it's not exactly doing floor either. I assume you guys have seen floor. You just truncate and you lose the whatever floating point there is. But it's not really doing that either. If you have minus 2/3, we would expect minus 2/3 to if we were just taking the floor, you would expect minus 2/3 to be -1. We'll see if that's true. But it's not true. What it's doing is it's truncating towards 0. So if it's positive, it takes the floor. If it's negative, it takes the ceiling. So it's always trying to get more towards 0. But if you're doing something like this, you really just want to use doubles. There you go. That's more what I expect when I look at 2/3. And as I mentioned, we don't have this exponentiation to fill out the BEDMAS. So that's a separate thing. So just like system is a class that's built into the language, we also have math. which has many different methods, one of which is math.pow. The way we use that is, in Python, you would expect to do something like 2 to the power of 4. But in Java, you have to be, again, a little bit more verbose. Math.pow, 2, 4. And again, this might do something you're not expecting. When we have two integers, we raise one to the power of the other. I would sort of expect another integer, but math mostly works on doubles. So as you can see, we get the double 16, not the integer 16. But just as we cast this double value to a float, we can cast this to an integer. And then we get an integer. Any questions? Cool. So in addition to the regular arithmetic operators, we have the comparisons, which I'm sure you've seen in Python. Less than or equal, less than, equals, greater than or equal, greater than, and not equal. So what this does is it takes two numbers, or number-like things, say 2, compare 2 to 3. So it takes two numbers, and it compares them, and it returns a Boolean. So we'd expect in this case 2 is less than 3 to return true. And it is, so that's good. We also have logical operators. So if we have a true value, we want to like check if two things are true, or if one thing or another is true. We would do and. So that's ampersand, ampersand, and that means and bar, which means or. So if we have true and false, we would expect that to be false. Perfect. So those are the logical operators. And so finally, we're getting to object. Java makes a distinction. So in Python, everything is an object, more or less. It doesn't really have anything that's not an object. You can always call methods on things. But Java makes a serious distinction between what it calls objects and what it calls primitives. So these literals, all these things that I discussed up here, bytes, shorts, ints, longs, floats, doubles, Boolean characters, those are all primitives. But composed of primitives, you build objects. So one example of an object is a string, which we've seen all over. All of these are string literals. And so we can say string s equals the string literal. This is a string. Print that out and run away. There you go. String is sort of a special thing. Normally we don't have a literal for any given object. String has built-in literals in the language, so you can do this. This is a value that is a string. Put this value into this string object. But normally you can't do that. And it's worth mentioning that in Python we have multi-line strings and we have single or double-quoted strings. Java doesn't really have either of that. It has just these double-quoted string literals. And it can't really span across multiple lines. Yeah. So the normal way that you would create an object is using the new syntax, like at some point we might want to create what's called a scanner. And I'll get into what that is later. But you would create a scanner by doing scanner sc equals new scanner. So that's the object creation syntax. I'll be getting into that momentarily. But before that, just want to talk about arrays, which have another special syntax. So we saw up at the top, I mentioned that this is an array of strings. The way that you would create an array of strings is by doing string array, so that's its type, array of strings, SA equals new string, and then instead of these parens that you would normally do with an object, you give it square brackets, and you pass in the length of the array that you want to create. And so that's a string array. And so in Python, you would use a for loop to be like for x in SA. We can actually do that in Java too. For, call them string st, and then instead of in, we have this colon for string st in SA. Oops. No, go back. We can print out each string. But we can't really print anything out until we actually assign some strings to these. So let's say SA at 0 equals, this is the first string. Say 4. 4 is the last one because it's 0 indexed. So it's 0, 1, 2, 3, 4. This is the last string. And I'm deliberately not setting 1, 2, or 3 because I just want to show you what happens when you don't do that. So, I'm just going to complain. So it prints the first string, this is the first string, and then nulls. Nulls are what happen when you have a reference to something, like a string, but you don't give that reference a value. It's by default a null. And so this happens with objects. It's different for primitives. So that's what that is. And we can see that we're looping over it with this for each syntax. Yeah, so we can even use this to loop over st again. We can use this to loop over the command line arguments, which is useful a lot of the time. And so the way you give it command line arguments, normally, with the C program, you would just do like the name of the program and then give it arguments. With Java, you have to run Java, hello world, and then everything after that is a command line argument. So these are args. So you can see that we're looping over them, printing out these, which is the first string in the arguments, R, second string, args, third string. So a loop construct that you don't have in Python is the three-part for loop. But it's very common in C-like languages. So we say for, and then the first part of the three-part loop is where you declare a variable to be your counter. So we would say int I, and we give it some value to start with. And the second part of the three-part loop, so you tell it you're going on to the second part. The first part is over by putting the semicolon here. So it's a statement on its own. The second part is the condition. So it loops as long as the condition is true. We'll say I is less than 2. And then we increment I. And in Python, you would do something like I plus equals 1. But Java has a slightly more succinct way of doing that. You do plus I or I plus plus. In terms of the 3.4 loop, they're exactly the same. But if you want to get into it, the plus I increments the variable and then returns the value after incrementing. Whereas I plus plus, oh God, what have I done? Whereas I plus plus, it increments the variable and then returns the value that the variable had before you incremented it. Sometimes useful. In the case of the 3.4 loop, they're exactly the same. All it does is it runs this code, and then it checks this condition. So it doesn't matter what this returns, really, as long as it does something to increment. And then again, we have a block into which we put some code. We'll print out those st values. Oops. Derp. So st is not actually defined. What we actually wanted to do was use I to reference some string in our SA array. So this is how you reference something in the array. Just like we're doing up here. Here we reference it and then assign it a new value. Here we're just referencing it so we get the value that it currently has. So we compile that. Oop. And then we print through all of the things, and then we print through just the first two. Cool. And so last thing I want to cover is how to read input from the command line, and that's where scanners comes in. So scanner is not a built-in object, so you have to import it. The way you do this is at the top, before your class, you add an import statement, import java.util.scanner. Java.util is the package that contains scanner. I mentioned packages earlier, at least in that they map to directories, but it's really just a way that Java has to split up classes and put classes together that are related to each other. So we'll import it, and now we can use this without throwing an error. But what we really want to use is a scanner that takes some input from the system in, the standard input. So we can also run a scanner on a file, and it would read input from the file. But in this case, we want to read input directly from the command line, so we do system.in, which is just like system.out, only out prints things to the standard out, in reads things from the standard in. And so the way we work with a scanner is usually using while loops, which are exactly the same as they are in Python. So while sc has a next object to grab, do this code. C dot get next. No, next line. So what this does is, while sc has a next line to grab, we get the next line here and print it out. So we'll see what that looks like. Probably save first. So you'll notice that in every previous example, we immediately went back to the command line where we could type more commands. Here it's just prompting us for input. So cool. So what it's doing is I've typed out that line, what is happening, and it wrote back what is happening. So it's properly checking to see if there's a next thing, and then printing out the line. I don't know if you encountered this in Python, but the way that Unix usually works is it has next as long as you haven't reached the end of file, and that's true even if you're reading in from the standard inputs. And so, I don't know about you guys, but my keyboard doesn't have an end of file key, but you can do it by doing Control D. Control D tells it give whatever's reading an end of file character, and then it stops reading because it no longer has next. So yeah. Any questions? Nope. That's everything I had prepared, so I guess you guys get to leave early.